Okay, so we have a panel here of all the speakers from today. And what I think I would like to ask is that I've prepared a few questions, which I think are of general interest, but I'd like to ask if the panelists would please answer them in a preset order so that we don't get too lost. So if I could ask John to give the first answer, followed by Nick, then Sue, Malin, Suong, and Giuseppe. That will allow us to keep some sort of structure in place when we can't see each other. And so the first question that I had is for everybody really: what is the greatest achievement of the last decade of composites automation in your industry or area of study? John?
Yeah, well, I think I gave that answer in my presentation. That's when I say the 107 and the race we had with blade length and say the increased masses and how to produce those ultra long and heavy blades. That's been our greatest achievement. Okay,
I think that's to be perfectly, that's absolutely obvious. In a sense, I didn't need to ask that question of. So if we get a hangover to Nick.
That's a good question, Kevin, because of course everything exciting was developed far longer than 10 years ago. So if you look back to, say, for example, discontinuous composites, Chevrolet were using those in their Stingray in 1953, and when you look at the first patent for the automated tape laying machine, I think was that your comment, that came from 1970. But in short, the thing I'm most excited about is the overmolding, the thermoplastic overmolding, where continuous fibers are combined with either organosheet or discontinuous fibers. And I think for mass volume production, that and high quality components, that's the thing that I'm excited about.
Yeah, okay. Can we move on to Sue?
So I guess over the last 10 years, the main step change for us from Airbus's perspective would be the introduction of composites for primary wing structures and the automation in terms of automated tape laying for those very large components. And of course, the program that we're now working on is looking ahead to the next product and how to take the automation to another level to meet higher volume production.
Thank you. So we could turn to Malin.
A difficult question, but a good one. I'm very excited about the simulation codes that comes now. That starts to connect the design, the production, and the mechanical properties that comes out from the component, so that we could do a really design for manufacturing. This is not any expertise I have, but I'm impressed by seeing what they do at companies like Volvo, other big volume production companies.
Thank you. Do you have anything to add, Giuseppe?
Well, yeah, I would say that from our perspective, the main achievement has also been the main challenge we've had, and I would say that is the scale up. I mean, if I remember back in the days, I mean, AFP systems were something I was working on when I was at university, well over 15 years ago. I would have never imagined that that technology could have been scaled up, not only in size, but also in volumes and in rates, to be able to, to produce components at the rates where the industry needs them, with the repeatability that the industry needs, and at the scale that the industry needs in order to develop primary structures. So from my perspective, is just the enlarging of making small coupons, university lab, all the way up to making wings and blades for real size.
Okay, thank you, Giuseppe. So you may have the last word on this question, Suong.
Yeah, okay, thank you. Well, for me, I think the most exciting is the availability of the automotive rubber placement to make surface revolutions using thermoplastic composites. That is the case where we can make very strong and supporting structures using automotive rubber placement, like we can make thick structures using carbon peak materials. So there is application to what we do here for Bell helicopter. So that is something that is exciting to me.
Okay, thank you for that. I think so that we've seen a lot of success over a very broad range of topics. But what I'd like to move on to is to ask you, what do you think the biggest obstacles are to further development of composites design and manufacture, both in your own areas of study or industry and the broader world? And if again we could start with John, that would be helpful.
I would actually rather turn it around and say what are the biggest opportunities, and I think there are multi opportunities for us. It's certainly to go to bigger blades, and when I look across the composite industry, I think the opportunities in the future is certainly bright. In my view, there is an increasing demand for composite structures. There is, one obstacle that I would like to point to. So with these increasing volumes of composites constructions, we will also need to handle bigger volumes of waste. So that's certainly something we need to think of. And in the wind industry, within the next years, we would see quite a large volume of end-of-life blades that needs to be handled, and we'll need to find solutions for that. So that's our focus for the coming period.
Thank you very much. So Nick, how are you seeing the next 10 years in the hub and beyond?
Well, there's a very good point there, Kevin. Things like, for example, if you take automated tape laying, the massively complex issue of the relationship between the material properties and the processing conditions, such as heat and rate and things like that. So I would hope that what we will see in the future is a much greater understanding of the mechanical processes and the parameters to give us a better chance of predicting the quality and the mechanical performance of the resulting structures.
Thank you, Nick. So from the Airbus perspective, Sue, what's the biggest obstacle to moving forward?
I mean, I think maybe to put it in the context of the biggest challenge or opportunity, as the previous panelists said, I would say repeatability and understanding the effects of defects is a huge challenge and a huge opportunity. And I absolutely agree on the sustainability point. I mean, we're by definition making a lot of plastic waste from the manufacturing process and in terms of the actual products themselves. And that is a huge challenge for all of us.
Okay, thank you. Do you have anything to add to that, Malin?
Looking at it from my perspective and sitting in Sweden, I would say that the biggest obstacles, I think, a lot of other industries that today active within the composite area that could have great benefits for using it. I think high material cost is still an issue. I can also see that the infrastructure for recycling is lacking, at least in our country. So there are things around this material cost, material recycling that need to be solved.
Thank you. And Giuseppe?
Yeah, I would say that if I had a magic wand today, what I would like to be able to make out of nothing is the knowledge of. It's probably building on what Nick said earlier. Relating the process parameters to the performance of the parts, but specifically on the long-term life of composite parts, because I feel that would unlock a lot of potential, and there are a lot of sectors there, oil and gas, partially energy, construction, infrastructure, that are reluctant to take composite components on board because nobody can guarantee that they would last as long as a steel and concrete structure would. We all know, we all feel perhaps that that is the case, that a composite bridge can certainly survive 120 years, but we've got no data to back that up, and our current modeling models to predict that are hard to validate.
Of course, thank you. That's very, very, very good point. Suong, do you have anything from your perspective to add?
Well, I think that from my point of view, there are two aspects. One is general, the other one is specific for myself. Generally, I think I agree with the previous speakers that I think the case of environmental concern in terms of recycling, how to reuse materials, because most of the composite we use are polymer based. And right now, the case of the plastics, pollution is really everywhere, and that is a big concern for society. So the future may depend on that is particular, that may be general for everybody. For my own personal kind of challenges, I would like to see the work on the problem of trying to address the distortion out of the thermoplastic composite structures, because these are the issues that appear and that seem to be very hard to address. So that distortion of composites, thermoplastic composite structures. Yeah.
Yeah, absolutely. So the next question I wanted to come to is really in two parts, and that's we've talked a lot about the technical challenges of doing all the things that we do, and I think we can almost take that as read at this point. I think you've answered probably most of the questions now about what you individually see as the most important technical challenge. But what I'd like your thoughts on the non-technical challenges. You know, we are technical people embedded in a much bigger world. So if you could let me have some thoughts on what the non-technical challenges that we may have to overcome to expand the use of composites. I would be grateful to hear your thoughts. Again, if we could start with John.
Yeah, one point that I actually would like to point at, that would be supply of material. Actually, the presentation on the structural batteries using carbon fibers, if that will really take off, then I would be afraid that would absorb a large portion of the available market of carbon fiber. And then we would have a problem producing the components we are producing. So material supply is certainly a concern for us, and we are very careful about that. And that's also why we sometimes are very conservative in the material choice we make, because we need to be sure that we have the materials available for the volumes we need to produce.
Okay, so the sort of supply chain stability is very important to you.
Yeah, and also sustainability goes into that, because I really, well, from LM perspective, we will demand our supply chain to use recycled material, because say putting waste into landfill, that's for us a waste of resources. So we need to close the loop within a circular economy, feeding the waste back into life.
Okay, thank you. Can we move on to you, Nick?
Yeah, well, thanks, Kevin. I think the biggest challenge is people, and I think we need more trained engineers. We need more trained engineers, full stop, but we need more engineers trained in composites technologies, because you know, frankly, I think we're just scratching the surface at the moment, and there's so much potential in these materials, in the multifunctionality in particular, but also in the direct strength and stiffness specific properties, that I think well-trained engineers is what we need.
Thank you. Sue, from the Airbus perspective.
Yeah, I mean, I was also going to make a people point actually, but maybe a slightly different one, which is that I think we're all still on a learning curve in terms of really understand how you design products in composite for manufacture. and how you really do optimize the way you design them in order to be able to make them cost effectively, efficiently, with a minimum amount of waste. So I think that people challenge, that particular aspect of developing people's skills is a key one from my perspective.
Thank you. So Malin, thoughts on Sweden?
A lot of things have been said already. I think this is something we talked about 20 years ago, but it's still difficult to find data on the composite materials in the data charts, especially when it comes to manufacturing related parts, characteristics. So maybe that was a different question, but it just popped to my mind that if these data would be a little bit more available, I think more people could have at least started digging into to understanding and starting at least looking into using composites.
Yeah, I think the general point is that if I want to go out and buy 2025 T6 aluminium, I can buy it from anywhere. Any aluminium stockist can sell it to me, but everything in composites is specific grades from specific. Is there any future in sort of trying to commonize some of our materials to make them more broadly available, which both from a supply point of view and from a data point of view? Giuseppe, the NCC should be leading on that.
Yeah.
Sure. We've got all solutions to everything, of course. Yeah, well, I would echo what Sue and Nick have already said. I was going to say skills. What the point I would make there, perhaps, which is what we see from our perspective, is that the concern is that the technology is moving faster than the people's skills development is. So we don't seem to be able to keep up. There is the need for more composites engineer, but now that we're moving, I mentioned the digital space, more into that space, it doesn't feel like the education and the background that we're providing the young engineers with is ready to address that. So there is a gap there that is growing bigger rather than smaller.
Okay. And Suong?
Yes, I think that the biggest issue that I can see here is the case of the input versus the output. I think composite is a very complex field. It takes a lot of effort and a lot of years trying to really understand what happens. So I agree with the previous speaker that the training, how do you really get people to really get to know the field itself? And if you spend that much time trying to really learn the technology, how much benefit do you get from it? It's the same that you invest a lot of time and money and things like this. Do you really get good return for your investment compared to you go into computer science, some other areas? Some years ago, some of the sales engineer from company mentioned to me that there was a joke. He said, how do you make a little money out of composite? The answer is by throwing a lot of money at it.
Yeah.
So, I mean, in that sense here, I mean, in terms of whether you get a lot of benefit from spending the time in composite, so that means how you attract people to come into the field. So that's my concern.
So my last question to you all was actually been prefaced by almost all of you as a question, but I'd like you to start thinking about what the answer is. So what is the best approach to training people in designing cost-effectively manufacturable composite products? Where do you start? Everybody knows it's a problem. And now, can we think about what the solution is, please? And as I say, we've only got 5 minutes now to come up with the way to make the world a better place. But can we try? Starting with John.
Yeah, great, thank you. First of all, I would also like to echo the importance of people, but I especially like the importance to bringing more women into the technical area. We are certainly looking for a higher degree of diversity of our workforce, and we are actively working into creating the interest for the technical part, going down into the low grades in school and working into that. I think as an industry, we also need to be part of the training and the people. So a stronger collaboration between industry and academia, that's for me a key point.
Thank you. And Nick, if you could take over from there.
Yeah, well, so I agree with that comment about the ratio of women in STEM subjects. Certainly in the UK, that's a big challenge for us. What I think from a point of view of designing composite structures, I think a strong solids background is the key. But really, for these structures to have any benefit over steel, we have to exploit the anisotropy of the material, and that only comes from having a very solid background in strength of materials and that sort of thing.
Thank you. Sue, from the Airbus perspective?
I think it's a actually tremendously complex question with a tremendously complex answer, to be honest. But in order to avoid repeating anything that's been said before, I won't repeat the point about more women, because obviously that point is always made much more strongly by men. I would say that we need to continue to work in a very manufacturing orientated way when we're developing our technologies and developing our products. By that I mean real co-design between the design engineers and the manufacturing engineers, real hands-on demonstrators like we work on at the National Composites Centre. I think that appears to be the best way to really understand how to manufacture composite components, which sounds very simple, but of course it isn't. This is a very, very complex topic.
Thank you. Do you have anything to add, Malin?
I heard you saying something about getting the new students into the track of doing cost-effective manufacturing. I think that requires like an overview, which you can't require from a young student or a young professional. But I think training in different fields, I definitely agree with you, Nick, that they need to have a solid background in solid mechanics as well. But understanding the manufacturing problems, how it works on the workshop, collaborating with different disciplines, I think that is important. So you don't kind of get stuck into one track immediately. I'm that kind of person, or I'm that kind of person. You need to understand have an overview over everything in order to do this correctly.
Yeah, yes. You need to understand the shop floor as well as the classroom.
Yeah.
Okay, and Giuseppe?
Yeah, if I can bank on that, I would absolutely mirror that point. I'm afraid to say that we don't have a silver bullet to sort all the problems out, but from our perspective, the best engineers we've seen at the NCC are those that are not blinkered by the specific area of their technology. So they are not technologists, but they can see things from a system perspective. And it is a challenge. I said that during my presentation, we've got 350 engineers. It's fair to say that there is a handful of those only that can do that today at the NCC. It is a very rare breed of people. Those can absorb the input from areas that are allegedly outside their familiar zone. But that is what is needed in order to, unite the different fields and the different aspects that you need in order to deliver what you're asking for.
Thank you. And Suong, once more, you may have the last word.
Okay, thank you. I think that before the student do the design, I would subject them to the manufacturer first, because there are students that really understand the mechanics, but more or less like a solid mechanics for metals, but they have no clue what a prepreg is. And the way how you make the composite, depends a lot, very different from the case of metal. So I would subject them at least to the exposure to the manufacturing environment for a while before giving them some of the principles of some mechanics of solids.
I would agree entirely. My students go into the lab and get their hands dirty before they go into the classroom. Thank you all so much. That's been really helpful to me, and I think it's Very
Kevin,
valuable.
Kevin, we have a few questions in the Q&A. Maybe you could bother the panel with those as well.
Okay, yeah, okay, there they are. So there's a few questions here. There's firstly from Gary Scott, are there any opportunities for TFP in the preformed of organo sheets or in more thermoplastic applications? I think we need a translator. So that's fiber placement effectively. If that's not a subject that anybody feels strongly about. So I'll move on to the second one, which is probably more broadly valuable. How do you see the AI developments would affect composites in future?
Well,
If any of you would like to respond to that.
well, I can tell you, Kevin, that we are testing, I would say, rather than exploiting still, some AI, the potential of AI in some of our closed loop process controls. And we're trying to do that by linking up the outcome of a process to the input into it. The limitation we've got in that space is that AI, in order to be in any way meaningful, requires a very good understanding of the process so that you can put some brains behind the machine learning algorithm. But that's something that we can find and provide. But the difficulty we find, at least from an NCC perspective, is the sheer number of data points that are needed in order for an AI algorithm to work. Even the numbers of parts that we make that are usually in the single digits, we struggle to do that. However, there are some technologies that offer the possibility of doing that simply because they are by nature data rich. For example, AFP. The amount of data that you can capture in a single deposition is phenomenal, and we are working in that space with those particular technologies. Others, like impregnation and fiber infusion, preform infusion, are more difficult to push in that direction. But there is, I would say that from our perspective, our conclusion as of today is that if it is handled cleverly, it can provide useful insights, if not answers.
Yeah, I see the potential of using AI for the prediction of failure in terms of composite, because the fracture and fatigue and failure composite still is not quite understood. So hopefully, maybe there's a lot of different kind of mechanism that is happening in there. So if there's a lot of data that may be generated, and hopefully AI can help us to address that problem.
Okay, one of the questions that was asked, we sort of have already covered. So there's one last question here from James McCardle. Is there any real compatibility between thermoset matrix use and sustainability efforts? In the context of developing a circular economy, do we need to purely focus on the reversible nature of thermoplastics, or should we think about engineering in reversibility into cross-linking based matrix materials? This is the last question that we have the time for. So if anyone would like to comment on that, it would be very helpful.
So Kevin, I could make a comment on that, really.
Yeah.
And yeah, I mean, I take your point, James. But if you think about the energy that's embodied in that thermoset matrix, and if you think about the energy that's used over the life cycle of, say, an aircraft or a road vehicle or something, the actual energy in the matrix itself is tiny. Typically about 3%, I think, most of the studies. So we have to, if we're considering sustainability, we have to do it on an accountancy basis, I think, where we look at literally the full life cycle of the component, rather than just building in a recyclability requirement at the outset.
Any more background on those subjects? Well, in that case, I think we've covered the questions that were in the Q&A, and I think you've done a very good job of trying to tackle the questions that I wanted to address. So I think we are getting really to the point of the end of this afternoon session. So really, it just falls me now to thank the presenters, all of whom have done a fantastic job and have really made a major contribution to what I hope has been an enjoyable experience for those people watching from afar. I'd also like to thank the staff from Bristol University and the NCC who supported this event behind the scenes and prevented me from falling over on many occasions. And especially the thanks to all of those attending for their interest and for their excellent questions. We hope to see as many of you as possible in Bristol next year for the live event of here. We will be disseminating more information about calls for proposal papers and so on in the near future. We will investigate ways to allow us to engage with people that can't be physically present. I think there's sort of a definite urge to involve as many people as possible as well as we can. And so once more, and lastly, thank you all for your involvement. And I hope to look forward to seeing you next year in Bristol at the University, the Bristol Composites Institute, and at the National Composites Centre. Thank you all very much for being here. Thank you.